Hi guys, so today we're going to be doing properties of exponents. This should be a review of what you've learned previously in pre-algebra as well as algebra 1, but we're just going to be reviewing them because you're going to see them at work in more complicated math concepts in the next couple of lessons. Okay? So I'm going to kind of combine example 1, 2, 3, and 4 so that way you can see the different types of properties of exponents all together, because oftentimes you won't just see one separately on its own. Okay, so we're going to start by simplifying each one, and then we'll get started. Okay, so here I have the quantity of 3x cubed y squared multiplied to the quantity of negative 4x squared y to the fourth. Okay. So what I'm going to do first is I'm going to group all of my things that are the same bases together. So 3 and negative 4, even though they're not the same base, they are both coefficients. So I'm going to group those together. Okay. Then I'm going to put my x's together, so x cubed and x squared. And then I'm going to put my y squared and my y to the fourth together. Okay. So 3 times negative 4 is negative 12. Okay. And then x cubed stands for x times x times x, and x squared stands for x times x. Okay. Y squared is y times y, and y to the fourth is y times y times y times y. Okay. So then let me just highlight so that way you can see this. All right. So this here is x cubed, right, x to the third power. This here, my x times x, is this x squared. Okay. Here, this y times y here is y squared. And then this y times y times y times y is y to the fourth. Okay. And so then, the negative 12 stays the same. I already simplified it from the 3 times negative 4. So this, how many x's are being multiplied together? X times x times x times x times x. There's 5 of them, so that is x to the fifth. Here, how many y's are being multiplied together? 1, 2, 3, 4, 5, 6. That's y to the sixth. Okay? And so there you go. Okay? And so what we learned from one of our properties is that we're multiplying bases with exponents. If their bases are the same, what we can do is that we can just add the exponents together, right? So here with the x to the third and my x squared, I can just add the exponents together and it becomes x to the fifth, which we see here, right? And here with our y squared and our y to the fourth, I can add them, 2 plus 4, and that's why it's y to the sixth, right? Because if the exponents were bigger, we're not going to spend all of our time writing it out, right? But based off of the definition of exponents, we know that we can add them, okay? Okay. So here we're going to do the same thing basically, right? Now, since we know that we can just add the exponents when the bases are the same, that's what we're going to do. So I'm going to group them together. So a to the negative third, a to the second, b to the fourth, and c to the negative first. Okay, negative 3 plus 2 is negative 1, so a negative 1, b to the fourth, and c to the negative first. And then when we have negative exponents, what we're going to do is they're going to move to the opposite side. So if they're on the numerator, if they're on top, they're now going to move to the denominator. And if they're in the denominator, they're now going to move to the top to the numerator. So here, since it's all in the numerator, right, b to the fourth is positive exponent, so it's going to stay where it's at. However, a and c both have a negative power, so now they're going to move to the bottom, and then the power is going to change signs. Okay? And then writing anything to the first power doesn't really change anything, so b to the fourth, a to the first, c to the first, or I can just write it as a and c. And there you go. Okay, then here's the next one, p to the third and p to the eighth. So let's go based on definition first. So p to the third is p times p times p, and p to the eighth is p times p times p times p, 4, 5, 6, 7, 8, right? And so here we know that anything divided by itself is 1. So p divided by p is 1, and 1 times anything is itself, so that doesn't change anything. P divided by p, p divided by p, so now this is all 1. And then here is p to the fifth, so it's 1 over p to the fifth. Okay? And so while multiplication, right, when we're multiplying bases with powers, we're adding. When we're dividing, what we're actually doing is we're subtracting. So p to the third over p to the eighth. What we do is we subtract, and it's always going to be top power minus bottom power. So 3 minus 8, that is negative 5, right? Which is why here you see, to get rid of the negative exponent, it's now moved from the numerator into the denominator, and when it does that, it changes sign from negative to positive. Okay. So then let's try the next one. A to the third, the quantity of a to the third, or a cubed, raised to the sixth power. Right? So remember, a to the third is a times a times a. So this is a times a times a. Okay, but this is being raised to the sixth power, so we're going to do this 6 times. So then 4, 5, 6, right? So a to the third here is represented by this. Right? And then the fact that this is then raised to the sixth power is why we see this 1, 2, 3, 4, 5, 6 times. And so how many times here is a multiplied to itself? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay. And so this rule demonstrates our power to a power property, which is why we learned that when we have something that's raised to a power, raised to another power, what we can do is we can multiply the exponents. And so 3 times 6 is 18, which is why here you see a to the 18. Okay? It applies also to quotients here. So we have the quantity of negative 3x over y raised to the fourth power. And so what it means is that we have negative 3x times y multiplied by itself. Four times. And so now, this then means negative 3 is multiplied by itself 4 times, and negative 3 to the fourth. X is multiplied by itself 4 times. And on the bottom, y is multiplied by itself 4 times. Okay. Negative 3 to the fourth, negative 3 times negative 3 is 9. Times negative 3 is negative 27. Times negative 3 is positive 81. And then x to the fourth, y to the fourth. Which is why, with the power of a quotient, we know that we can basically take this power and distribute it to each of the bases, which is why it's negative 3 to the fourth, x to the fourth, y to the fourth, which gives us this. Okay. So last one here before you try some on your own. Okay. So what we're going to do knowing this, we're going to distribute, okay, to each of my bases. Okay. So then this becomes negative 2 to the 4th. Okay. It's important that this negative 2 here is in parentheses, okay, because if not, then only the 2 is being raised to the power and the negative is not. Okay. Then here, x to the 3n, so 3n times 4 is 12n, so 12n over 4 times 2n is 8n, so x to the 8n, and then 3 times 4 is y to the 12. Right? And then using our quotient property, we saw this before, that it's top minus bottom. So here I see x on both sides, on the numerator and in the denominator. Okay. So then I'm going to take my top power, which is 12n, and subtract it from my bottom power, which is 8n. Okay. Then I'm going to simplify, so negative 2 to the 4th. Negative 2 times negative 2 is 4, times negative 2 again is negative 8, times negative 2 again is 16. So this negative 2 to the 4th simplifies to 16. Okay. X to the 12n minus 8n, 12n minus 8n is 4n, so this becomes x to the 4n, and then this is y to the 12. If you look in the book, you'll see that they have another way to do it, and what that means is they just distributed this to the 4th power first, and then they distribute this 4th power and then simplified it. But either way, you'll still get the same answer. Okay, so why don't you try check your understanding, not check your progress, but check your understanding numbers 1, 3, 8, and 9, and when you're done, come check your answer. Okay, for 1, you should have gotten negative 15 x to the 7th, y to the 9th. 3 is negative ab to the 4th over 9. 8 is 9p squared q cubed. And then number 9 is 1 over 4 x to the 6th. If you got those right, you can move on to the last example. If not, here's your explanation. So with number 1, I grouped the coefficients together, so negative 3 and 5, and that's what gave me the negative 15. Then I grouped things that were the same bases together, so the x squared x fifth and the y cubed y sixth. Okay. Then, when we're multiplying bases with exponents, if they are the same base, we can just add the exponents. So 2 plus 5 is 7. 3 plus 6 here is that 9. Okay. Number 3 here, I simplified each part. This is the quotient property. So negative 2 over 18 is negative 1/9. There's no need to write the 1 at least because there's other things that's going to be on top. So that's where the negative and the 9 comes from on the denominator. Okay. Then a cubed over a squared. When we're dividing the same bases but with exponents, we just subtract, and it's always going to be top minus bottom. Okay, so 3 minus 2 is 1. A to the first is just a, so that's why a is here on top. Okay. And then same thing with b. B to the 6 over b squared. It's always top minus bottom, so 6 minus 2 is 4, so that's why b to the 4th. Okay. For number 8 here, okay, what I did is I distributed this squared. So this becomes 3 squared, p 2 times 2 is 4, and then q has an exponent of 1, so 1 times 2 is 2. Okay. Then 3 squared is 9. Okay. 81 divided by 9 is 9. P to the 6th, p to the 4th, 6 minus 4 is 2. And then q to the 5th over q squared, 5 minus 2 is 3. There you go. Okay. And then number 9 here, we have a negative exponent. Okay. So I did it in 2 different methods. So with the first method, I just simplified what was in the parentheses first. So negative 6 divided by 3 is negative 2. And x to the 6th, x to the 3rd, 6 minus 3 is 3. And then the power, I haven't done anything with it, so it stays the same. Because it's a negative exponent, it's now going to flip, which is why this is all at the bottom here. Okay, and then and after you flip it, the power turns positive. So negative 2 squared is negative 2 times negative 2, which is 4. And then x cubed squared, 3 times 2 is 6. The other way you can do it is you can distribute that negative 2 first, so that's why it's negative 6 to the negative second. 6 times negative 2 is x to the negative 12. 3 to the negative second here, and then 3 times negative 2 is negative 6. Okay? Then, because they're negative exponents, they're going to switch places, so that's why here the ones in the denominator with negative move up, and then the ones in the numerator with negative move down. Okay? Then I simplify. 3 squared is 9, negative 6 squared is negative 6 times negative 6, which is 36. 9 over 36 is 4, or 1/4, right? And then x to the 6, x to the 12, 6 minus 12 is negative 6, which is why it moves back to the bottom here. Okay, so now we're going to do example 5, which is our word problem. So here, after the Sun, the next closest star to Earth is Alpha Centauri C, which is about 4 times 10 to the 16th meters away. How long does it take light from Alpha Centauri C to reach Earth? And then just extra need is light travels at a speed of about 3.00 times 10 to the 8 meters per second. Okay. So what we're going to do is we're going to divide how far it is with this, right? Because we know that distance equals rate times time. This here is the rate. To get the time, then we're going to have to do distance divided by rate will give us the time. Yep. So that's what we're going to do. Distance is 4 times 10 to the 16th meters. Okay. Rate is 3.00 times 10 to the 8th meters per second. Okay. This will give us our time. And then remember, meters divided by meters per second. So meters divided by meters per second. If you remember how we divide fractions, we keep the first one, we flip the second one, and then we change the division to a multiplication, which is why the meters and the meters cancel out and only gives us seconds, which is that time that we have. Okay, so then what we can do is we can do 4 divided by 3, and then we can do 10 to the 16th over 10 to the 8th. And then we saw here that the meters divided by the meters per second just gives us seconds. This will be our time. Okay. So 4 divided by 3 is 1.33333333. So we're just going to keep it to 2 decimal places here, so we're going to leave it as 1.33. Right. Here, since it's the quotient rule, 16 minus 8 is 8, so this will be 10 to the 8 seconds. Okay. So how long does it take light from Alpha Centauri C to reach Earth? 1.33 times 10 to the 8th seconds. Okay. Or what this means is that it's 4.2 light years away. So this is how long it takes. Okay, so why don't you try CYP5, and then once you're done, come check your answer. Okay, you should have gotten that the density of platinum is 2.1 times 10 to the 4th kilograms per meters cubed. If you got this right, you can get started on homework. If not, here is your explanation. Okay. So the first sentence in number 5 gives us the formula. It tells us that the density of an object is found by dividing the mass, m here, dividing that by the volume. So D equals m divided by V. Okay. Here it tells us that the sample of platinum has a mass of 8.4 times 10 to the negative 2nd kilograms. So that's here, that's my mass, so I replaced m with that, 8.4 times 10 to the negative 2nd kilograms. Then it tells me that the volume is 4 times 10 to the negative 6 cubic meters. So that's 4 times 10 to the negative 6 cubic meters here for volume. Okay. Then I just simplified 8.4 divided by 4, and then 10 to the negative second over 10 to the negative 6. 8.4 divided by 4 is 2.1. And then 10 to the negative second over 10 to the negative 6. This is the quotient property, so it's top minus bottom, right? So top, negative 2 minus bottom, negative 6. Negative 2 minus negative 6 is 4, so 10 to the 4th. There you go. Okay. So that's it for today. Have a great rest of the day. Bye, guys.